Hi everyone! It is that time of the week again where we go over our weekly math problems just so that you guys can have a detailed explanation as to how to do all of them so that when we have a test soon, you guys will know exactly how to do these problems. So y'all know we have recently been studying geometric figures from chapter 9 and y'all already have your homework questions. So we're going to just go ahead and get started with question 1 from your homework assignment. So this is the part of the problem that we're given. We're supposed to find all of the measures of the angles, and we're also given these two parallel lines. So to find each measure, we have to begin by finding the measure of all the interior angles right here. We learned that for a triangle, all of the interior angles have to measure up to equal 180 degrees. So let's use the information that we have to solve for angle 7. The first thing we can do is 180 degrees, because that has to equal the whole entire triangle, minus 63 degrees minus 61 degrees. And that equals 56 degrees. So that means that angle 7 is going to equal 56 degrees. Next, we're going to find angle 1. Notice that angle 1 and angle 7 are corresponding angles. We learned that corresponding angles are always equal to one another, so this means that angle 1 and angle 7 are going to have the exact same measure, which is 56 degrees. Now moving on to angle number 2, the angle opposite of angle 2 is 63 degrees. Now we have also learned that vertical angles, which are opposite angles, are always equal to one another. So if the opposite angle of angle 2 equals 63 degrees, that means that angle 2 is also going to equal 63 degrees. Now for number 3, let's notice that the angle given to us right here is 61 degrees. You see how 61 degrees corresponds with angle 3? We know that corresponding angles are always equal, so once again, 61 degrees is also going to equal angle 3 since these angles are corresponding. Now for angle 4, we'll use the same concept of a vertical angle and we'll look at its opposite angle, which is angle 3. And we just solved angle 3, which was 61 degrees. So since that's opposite of angle 4, that means angle 4 is also going to equal 61 degrees. Now, number 5, the angle opposite of angle 5 is angle 1. So there's a lot of vertical angles that you're probably noticing in this problem. So once again, 56 degrees is the angle opposite of angle 5, so that means angle 5 is going to equal 56 degrees as well. Now let's go ahead and jump down to angle 6 down here. The angle on the right side of angle 6 with a value of 61 degrees is a supplementary angle with angle 6. Supplementary angles always have a sum of 180 degrees. So this means that angle 6 equals 180 degrees minus 61, and that equals 119 degrees. Next, let's find angle 8 since we've already found angle 7. The angle on the left side of angle 8 is angle 7, and it's the exact same concept we just used over here. Since these two angles are supplementary, that means we can do 180 minus 56, and that equals 124. So that means that angle 8 is 124 degrees. Now we'll move on to angle 9. We know the angle opposite of angle 9 is 61 degrees. So once again, vertical angles are always equal. So that means angle 9 will equal 61 degrees. And same with number 10. The angle opposite is angle 6, which equals 119 degrees. So that means angle 10 will also equal 119 degrees. And over here, angle 11 equals 124 degrees because it is vertical angles with angle 8, which equals 124 degrees. And I bet y'all know what angle 12 equals. Its vertical angle or opposite angle is 56 degrees. So that means that angle 12 is also 56 degrees. So now the values for every single angle are now shown. And this graph or chart will give you guys a rundown of all the similar angles and the supplementary angles. In this last problem, we didn't have any complementary angles, so you don't have to worry about that one in this last problem. But these will give y'all a better understanding of those two angles. Now for question 2, we are also going to be solving the measure of some different angles. And we are only given the measure of 2 angles in this problem, which is 74 degrees and 26 degrees. So we are going to solve for angle 1 first because we know that a triangle, all the measures have to equal up to 180 degrees. So we can do 180 minus 26 minus 74, which are these 2 points in the triangle, and that equals 80 degrees. Now, for this next part, if you need to extend the parallel lines like this to help you identify corresponding angles, go ahead and do so because it helped me understand this next part. So now from the figure, you can tell that angle 3 and angle 8 are corresponding angles to angle 1. Since corresponding angles are always equal, this means that angles 3 and angle 8 are going to equal 80 degrees, just like angle 1 does. Now, angles 2 and 3, these two angles are supplementary, and we talked about supplementary angles in the last problem. So this means in order to solve for angle 2, we would do 180 degrees because the supplementary angle always has to measure up to 180 degrees. So 180 degrees minus 80 equals 100 degrees, and it's the exact same thing for angles 7 and 8 down here, which had the same measures. So now we solved angles 2 and angle 7, which was 100 degrees. Now notice that angle 5 and angle 3 are alternate interior angles. Therefore, angle 5 is congruent to angle 1, 3, and 8, giving it the measure of 80 degrees. Now there are only 2 more angles we have to solve for, which are angles 4 and angle 6. So we can go ahead and figure out angle 4 based off of the information that we have. So if you look closely, angle 4 and angle B, which equals 26 degrees, are corresponding angles. So since corresponding angles are always equal, that means that angle 4 is also going to equal 26 degrees. And angle 6 is corresponding with angle C, which is 74 degrees. And since corresponding angles are equal to one another, that means that angle 6 is also going to equal 74 degrees. So now we've solved question 2, and here's another chart for y'all to look at that have the similar angles and the supplementary angles on there for you. Now question 3. I always like that animation. So to solve this problem, we need to realize that the sum of the measures of the interior angles of any polygon that you're going to be solving for will be n minus 2 times 180 degrees, where n equals the number of sides. So n is super easy to find. You've just got to count the sides of your polygon. So let's go ahead and do that. So we've got 1, 2, 3, 4, 5, 6, 7, and 8. So that means that n is going to equal 8 since we have 8 different sides. So we're going to plug 8 into this formula, which gives us 8 minus 2 times 180 degrees, and that equals 1080 degrees. Now what we're going to do is set the sum of the measures of the interior angles, which are all of these, equal to the value of the sum of the measures of the interior angle, which is 1080 degrees. So you can see I've got that set up right here for you with every interior angle. And all you're going to do from here is solve for y. So that means we're going to simplify the left side. We're going to add all of those numbers together. And we get 54y equals 1080 degrees. Now we're just going to simply divide by 54 on both sides. And when we do that, y now equals 20. So now we're going to just substitute y for every y value that we see within our polygon. So when we do this, we get 3y, which equals 3 times 20, and that equals 60 degrees. So notice how every 3y equals 60 degrees. Next, 7y, which equals 7 times 20, equals 140 degrees. So notice how every 7y equals 140 degrees. And lastly, 12y equals 12 times 20 equals 240 degrees. And that means that every 12y we have is equal to 240 degrees. So it's super simple. You've just got to count the sides, make an equation, simplify it, and plug in your answer into each of the interior angles. Now, question 4. In a regular n-gon, which means any polygon that you work with, each interior angle has a measure of n minus 2 times 180 degrees divided by n, while exterior and central angles, they have 360 degrees divided by n. That's their measure. So in order to figure out what the value of n is, we once again have to count the sides of our polygon. So when we do that, we'll start down here. We get 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. So n equals 9. And now all we're going to do is plug in 9 into the formula right here. So for interior angles, we get 9 minus 2 times 180 degrees divided by 9, and this equals 140 degrees. So that means that our interior angle right here is equal to 140 degrees, and every single one of those will be. Now, exterior and central angles, fortunately, they both have the same formula. So you can do just one formula for both of them, which is 360 degrees divided by n, which will be 360 degrees divided by 9, since we have 9 sides, and that equals 40 degrees. So that means our central angle right here is 40 degrees, and that means our exterior angle is also 40 degrees. So now we are at question 5, just 2 more questions left, and we've got this cube. So this problem asks us to construct a cube with vertices A, B, C, D, and then E, F, G, and H. Then, in a different color, we're supposed to construct vertices D, E, G, and H, and these will be the vertices of a tetrahedron that is inscribed inside of this entire cube. Then we're just going to construct the faces of the tetrahedron as subsets of the faces of the cube. And this is what it's going to look like. This means that none of the faces of the tetrahedron will be overlapping or resting on any of the faces of the cube. So for example, the face of the tetrahedron BDE, it shares a few of the same vertices along with the cube. But its actual face, which is right here, it does not overlap and it does not rest on the face of the cube, which is A, B, C, D. They share the same vertices, but they're not overlapping faces. So this is how you know that you've done this problem right. And because of this one, we can tell that the other faces also don't overlap. So it's true for the whole tetrahedron. So it's a very easy guess and check visual. You can just check it by looking at it and see if it overlaps with any of the faces of the cube. So this one's pretty easy, and it's fun just, constructing the cube and the tetrahedron. I liked this problem. Now, question 6. For this problem, we are first asked to draw a tetrahedron, and we just worked with the tetrahedron, so y'all should know that a tetrahedron, it is a solid that has 4 planes that are triangular faces. So this is what it would look like, and it probably looks like the one from the previous problem. And notice the prefix tetra. Tetra means 4. You'll find that in math, you'll find that in chemistry. It always means 4. It's universal. So that's how you know it's going to have 4 faces, 4 sides. So let's go ahead and count those just so we can prove that this is truly a tetrahedron. So we've got this face right here, which is 1, this one, which is 1, this one right here, and then this whole face right here. So that equals 4. So that's how you know this is a tetrahedron. Next, we're asked to draw an octahedron. Now this one gets a little more complex because notice the prefix octa. Y'all probably recognize that. That means 8. So that means that this shape is going to have 8 different faces. So an octahedron, the definition says that it's a 3-dimensional shape having 8 equal triangular plane faces. So let's go ahead and count these sides as well. We've got 1, 2, 3, 4, 5, 6, 7. And then this whole face right here equals 8. So therefore, we have successfully drawn an octahedron. Now this next one, icosahedron. This sounds really complex. Y'all might be scared. But it's nothing to be afraid of. You can definitely handle it. So an icosahedron, what is it? So an icosahedron, it's also a solid figure that has a triangular base, and it has 20 equal triangular plane faces. So, we've got 4 here, we've got 8 here. Now we've got 20. Now, I know this looks kind of hard, but we can also count the faces for this one. So let's go ahead and start right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to move inside. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And this whole face right here equals 20. So y'all just successfully drew an icosahedron. Isn't that awesome? So we just finished y'all's homework, and I hope that it helped you guys. I hope that you'll be able to use this as you prepare for future homework problems. But you can always refer back to this video. You can always ask me questions. I would love to help. So thank you guys so much, and I hope you guys have a wonderful evening. I will see y'all in class tomorrow. Thank you.